Welcome everyone. We're going to try something new today. This is the way I've tended to teach math in the past. It's called flip learning. But instead of for homework, we're going to use it in the classroom to kind of give it a go. So what's going to happen today is we're going to take a look at Unit 2, Chapter 2, Lesson 8, moving on from mental strategies and multiplication. I know for some of you that might be a little bit anxious because 2.7 has been kind of tricky. So what I'm going to do is I'm going to get us started with Lesson 8, and then I'm going to send those Red Chili challenges on their way to keep working in their interactive student edition, and then I'm going to pull the rest of you to keep working with me. So have your whiteboards ready to go. Just a reminder that we are going to be doing all of our work inside of our math journals, and just to go over how that works again, you should have the lesson title there, the date. You need to circle the number of the problem to show that it's not a digit in the problem, and you need to make sure that it's nice and clear. And sorry, I'm using my husband's computer. So you can also use these for notes. If you haven't been doing that well, now is the time to start. All right? All right, well, let's get started with the warm-up problem. All right, so let's think about it. So this is a problem that you will see. This is a fourth grade problem for the end of the year. If there was 100 children, 86 of them got it right, and 14%, 14 out of 100 would have gotten it wrong. So what is 874,000, because there's the comma, 562 rounded to the nearest hundred? What it would have you do is use these boxes to create your answer, so you might actually have to use one of these numbers more than once. So pause the video, do it on your whiteboard, and give it a go. All right, hopefully you paused the video and gave it a go. So what I did is on the next slide, I actually gave you the answer. So many of you probably thought this was pretty easy. I used this strategy where I circled the place value it was looking for. It was looking for the nearest hundred. So 5 was in the hundreds place. I circled that. And I underlined that number right to its right. Because that's the one when we use our fun reminder, if it's 5 or above, I give the place value on a shove. If it's 4 or less, I let that place value here rest, that's circled. And so I know that it's 6 is 5 or above, so I'm going to give that 5 a shove to a 6. Now all these digits to the left stayed the same, so they're still 874,000. The 5 changed to a 6, it got shoved up. And then the place values to the right, which was the 10s, the 1s, went to 0. So there's the actual answer. But what if you had to explain your reasoning with math words? Well, here is my example. Because 874,560 is closer to 874,600 than it is to 874,500 on a number line. That's why I did that. So see the model. So here's my model right here. So what I did is I made 874,500 because I was rounding to the hundreds place. So I knew this digit would either go to 500 or to the 600s. The 874 stayed the same, but I would either shove up to 600, which is right here, or I would let it rest at 500. So I made a number line with 874,500. All the way to the right, I put my 874,600. And then what number was between the two of them? Well, between 500 and 600 is 550, right? The 874 stays the same, but it's 550. So I put that in the middle of my number line. Well, then when I graphed 562, well, you see it's just a little bit, actually it should be a 62 there, right? It's just a little bit to the right of the middle, which means it's closer to 874,600. So that's actually why when you go 5 or above, you give it a shove to the next highest place value, because on a number line, if you broke it up by place value that you're looking for, 500, 600, that number of 5 or above, that 500, you'd push up to 600. If this was 549, right, 49, I would be closer to the 500 than it would be to the 600. So that's why 4 or less, we let it rest, but 5 or above, we give it a shove up. All right, so that's how you would explain that thinking, and this would be a beautiful example of a model. All right, let's get into the lesson. Here's our vocabulary. We're going to talk about factors and products in a bit, but what I want you to do is, as I'm talking about it, what share out on your whiteboard which of these vocabulary words you're really starting to learn that you didn't know before. So remember, partition, the T-I-O-N, means act of, so you're in the act of breaking something into parts. Sum is numbers to be added, the total amount altogether. This distributive property, all right, it states that multiplying a sum of a number is the same as multiplying each addend, that should be addend, by the number, and then adding all those products and multiples together. So if this was 16, right, 5 groups of 16, what it's saying is that I could break up 16 into 10 plus 6. And if I had 5 groups of 16, that's the same as 5 groups of 10 plus 5 groups of 6. So what I've done is I've distributed that 5 groups of, and I've broken up this other one into parts. And that makes it a lot easier on me, because what I want you to do is I want you to think about the difference between multiplying 5 groups of 16, or could you easily solve 5 groups of 10, which is 50, and add to that 5 groups of 6, which is 30. All right, so that's what the distributive property means. It means you're taking this value that you can break up into 10 plus 6, and you're going to take those 5 groups of, and you're going to distribute it across these addends. And we'll see that today. Estimate is to find roughly the amount, but not exactly, but close. And partial product is right here. 5 groups of 10 is the partial product of 5 groups of 16, and 5 groups of 6 is the partial product of that 5 groups of 16, and then I add those partial products to get the whole product. We'll also be talking about associative property today of addition or multiplication. It does not work with subtraction or division, but the associative property means if I have 3 numbers that I'm adding together, it doesn't really matter which ones I add first. I don't change the order in associative property. I keep that the same, all right? But instead of doing the 8 plus 5, I could have added the 3 plus 8 first, and that is shown by these parentheses. In multiplication, it also works. If I'm multiplying 3 groups times 4 times 2, I can multiply the 3 times 4 first and then times 2, rather than multiply the 4 times 2 first, because that's what's in the parentheses, and then multiply by 3. But you notice the order of the numbers didn't change. Well, that's different than the commutative property, which is also addition or multiplication. That C stands for changing the order. So let's look at these same numbers. I had 3 plus 8 plus 5. Well, look, I'm moving the 8 plus 5 first and then adding the 3 at the end. And multiplication, if I'm multiplying 3 times 4 times 2, I'm moving the 4 times 2. I'm changing the location times 3. So the C in the community means changing the orders. And we're going to talk about that in mental math, because grouping them differently or changing the order really helps you solve problems better. For factors and multiples, I'm going to be showing you this chart every day for a while. Factors are these gray boxes on the outside. These are your groups of and how many are in your groups. Those are your facts. And then inside the box are your product of when you multiply these facts together, or also called the multiples. So these are your multiples in your facts, and these are your factors. So 5 times 6 is equal to 30. The factor pair, there's 2 numbers in a pair, are 5 and 6. 30 is the multiple. So 30 is the multiple of 5 and 6. 30 has the factors of 5 and 6. Those are different ways of saying it. 5 is a factor of 30, which would make 6 a factor of 30. And 30 is a multiple of 5. 30 is an even number, so would 2 be a factor of 30? Absolutely. Even though it's not on this board, it would be in the middle of this square got larger. So 30 is a multiple of 2. 2 is a factor of 30. Can you think of any other factors of 30? So at the end of this lesson today, you're going to be still using those models and strategies to multiply one digit by multi-digit numbers up to the thousands, and you need to be able to explain the pattern. This is what makes 4th grade a little bit tricky. It's not just calculating, but being able to explain patterns and why you're doing things, and be able to use models and strategies and be able to show those strategies in use. And I feel like that makes it tricky. So I was thinking that the red group would kind of head out on their own, but I want you to stay with me for a while and then we'll come back to the screen. I also want you to know that if you finish your work today or any day, we're going to start making sure we do extra math for just 10 minutes or one lesson every day. And you can definitely do that at home because this extra math is giving you those basic facts for multiplication, addition, division, and subtraction, and you get a really neat certificate. So make sure we're practicing this over Prodigy right now, okay? All right, so let's take a look at using mental math. So here's this problem. There are 4 sections of seats in the Playhouse Theater. Each section has 7 groups, and in each group there are 25 seats. All right, that's already getting kind of confusing, but it's definitely real life. So how many seats are there in this theater altogether? So stop the video and talk to each other. Why is this problem hard? All right, well, I'm going to start moving this around and tell you. Hopefully you pause the video and you're ready to go. Now, I am actually going to click away into my Lumens, and you're going to get to actually see my work. Hopefully this works well. There we go. All right, here we are. Make it a little bit bigger. I'm going to pause it. All right, so here's my math journal. First thing I'm going to do is put my lesson. My lesson is 2.8 today, and the date is October 18th, 22. So make sure you start putting the lesson up at the top, and you can use the title if you want to. I would love that, actually. All right, so I took some notes from problem number 1. So you notice I put the 1 in the circle. I had 4 sections, and 4 sections, each of those sections had 7 groups, and each group had 25. Well, this is just a lot for me to process. So what I'm going to do is I'm going to draw a picture. Well, first I had how many sections? I had 4. All right, so I'm using my boxes to keep my thinking neat. But then inside each of these sections, I had 7 groups. So already that's getting way too hard for me to even show a model of, isn't it? Okay, because there needs to be 7. How would I do that? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So each of these sections, right? There were 4 sections. 1, 2, 3, 4. Each of these sections had 7 groups. So how many groups do you have all together? 7 plus 7 plus 7 plus 7, or 4 groups of 7, 4 groups of 7. So you can see we already have 4 groups of 7 groups. We have 28 groups all together. Would you agree on that? But guess what? In each of these little groups, there is 25. I can't even draw that well, right? 25, 25. Each of these have 25. So there are 7 groups of 25 in these 4 groups. Does that start to make sense? So each one of these little groups has 25, and I can't even model that well because my pen's too big. So think about how hard that is modeled. So I have 4 groups of, I have 4 sections of 7 groups that each have 25. So 4 groups of 7 and 7 groups of 25. So that is the expression, which just shows the operation. And then I need to solve it and turn it into an equation. And remember, an equation is the act of making it equal. All right, so let's take a look. Well, what is really cool about the distributive property, okay, the distributive property is this probably looks hard, but I can rearrange these numbers to make it easier. Well, the first thing I'm thinking of is that's tricky for me. All right, or you know what? I could break that up into 20 plus 5. That might make it easier for me. Would that make it easier for you? That would be the distributive property. Or I could use the, do you remember? Not comparative. Oh, see, I even forget them sometimes, right? The commutative property. I can change the order. So what if I changed the order? So the commutative property, and I'm going to change the order. That's C for change. What if I did 4 groups of 25, and you notice I'm keeping my digits in the box, and then later I multiplied that by 7? Well, you should know that. Here's 1 group, here's 2 groups, here's 3 groups, here's 4 groups. Hopefully you know that 4 groups of 25, 4 quarters are equal to what? 100, right? Do you know that? So 4 groups of 25 is 100. Now look, because I've used the commutative property and I have changed the order, now I'm multiplying this 100 times 7. Well, heck, I know that's 700. So do you see how this original problem looked tricky? But then I reordered it because I wanted to do mentally the problems I could. Since I knew that 4 groups of 25 was 100, and I just knew that in my head, and I knew that in my head that's 100 groups of 7 or 7 groups of 100 was 700, I could solve that problem without really doing too much work. So that's the whole idea behind mental math. The idea behind mental math is just deciding what factors, A times B times C, could you multiply quickly. If you could multiply A times B really easy, then multiply C, awesome. But maybe A times C is easier for you to do first. So I'm going to use that commutative property. And then I'm going to multiply B. Or maybe I don't even have to change the order and I can use that associative property where I just decide I'll do A last here, but I'll do B times C first. Now, before you freak out and think, because I know my algebra, take a look at what I'm saying. Let's say your 9s are tricky. So let's say you had 2 times 9 times 5. Well, is there anything out of these 3 numbers that you could multiply in your head really fast? Well, if I use the commutative property and I move the 9 away, but I do the 2 times 5 first, and then I sort of leave that 9 for later, can you see 2 times 5 is equal to what? 10. Well, then let's multiply the 9. Well, what's 9 groups or 10 groups of 9? 90. So what kind of looked tricky at the start for you can become easier by using these properties, and that's why it's important to know. Now, sometimes maybe A or B or C is just a really big number. And what we need to do is we need to break these numbers into place value. We need to expand them. Expand it into place value. That was the lesson some of you had found tricky. So I'm going to give you an example. I'm going to make 165 times, let's say 5. Okay? Well, some of you now are learning how to do that, but let's say for me that was tricky. So I'm going to break this number up into its place value. I'm going to break the hundreds and bring them apart. So how many hundreds do I have? 1 of them, 100s, and I'm going to multiply that by 5. Then I'm going to take out my 10s. Well, how many 10s are in this one? 6 10s. And I'm going to multiply that by 5. And then I'm going to take this 5 and I'm going to multiply that by 5. So I have broken 165 up into its place value. It's hundreds, it's 10s, and it's 1s. And I have used that idea of the distributive property because I'm multiplying all of them by 5. 5 groups of 165 is the same as 5 groups of 100, 5 groups of 60, and 5 groups of 5. Well, what's 5 groups of 100? 500. What's 5 groups of 60? Well, 6 times 5 is 30. And then what? I have how many zeros I'm adding? 1 0 right there, so it's 300. 5 groups of 60 is 300. 5 groups of 5 is 25. Now remember, you have to line up that place value and see how I'm making real careful to have 1 digit in a square. 0 add 0 add 5 is 5. 0 add 0 add 2 is 2 10s. 5 add 300s is 800. So 165 times 5 is equal to 825 altogether. This was using that expanded form, which is also called partial product. Okay, it's also called partial product because this is part of the product of 165 groups of 5. This is part of the product, and this is part of the product. Then I took all those partial products and I added them together. All right, so my red chilies, if you get this, you are out of here. You can go take a look at 2.7 and finish that off. And I know we already have somebody on 2.8, so go ahead and give that a go. If you find this is tricky, go ahead and pause the video for a second, get your whiteboards and sink in. We're going to really work through some problems together. I'm going to give them to you and work through them. All right? All right, so let's take a look. All right, so here we go. Ready on your whiteboard. We have 6 times 10 times 10. Does anybody see any patterns in that number that might make it easy to solve? So 6 times 10 times 10. I mean, those are 3 digits, right? That just seems like a lot of work. I don't know why it's so... There it goes. So, there it goes. I'm going to turn off that light. Sorry, guys. All right, 6 times 10 times 10. Oops, sorry. I'm not using every digit in a place for you, Mr. Mossy. What am I doing? Make sure I do this correctly, right? All right, now because the parentheses are around the 6 and the 10, and this is my problem number 2, it wants me to multiply those numbers first. But you know what? I need to use what I know my strengths is, and I'm really good at my 10s. So what I'm going to do is I'm going to use that associative property. I'm not going to change the order. I'm just going to multiply them, keeping the numbers in the same order, but I'm just going to multiply my 10s first. Well, what's 10 groups of 10? 10, 20, 30, 40, 50, 60, 70, 80, it's 100. So see how I put that arrow down there, 100? Now I'm just doing 6 groups of 100. What's 6 groups of 100? You got it. That's equal to 600. So by doing that, it seems pretty easy. So I want you to see about this next problem. See if you can, I've kind of already given you a clue. See if you can do this one on your own. Pause the video. All right, hopefully you paused the video. So we have 4 times 9 times 250. Oh my gosh, these numbers are getting kind of big. This is problem number 3. 4 times 9 times 250. Well, I'm going to be honest, I don't really care what order it's telling me in because I'm already thinking if I was to do 4 times 9 first and end up with 36 and have to multiply 36 by 250, that would be way too hard. So now I'm going to use that commutative property. Remember that one? The commutative, where I'm actually changing my C there. I'm changing it around. So I'm going to do 4 times 250 times 9. Why did I change the order? Well, because I see that this is a property of 10. So this is really like 4 times 25, right? And then just adding that 0. Well, what's 4 quarters? What's 4 25s? What's 25 plus 25 plus 25 plus 25? That's 100. So I know that 4 times 25 is 100. And then if I add that 0 to it, it is what? 1,000. So 4 groups of 25 was 1,000. Now I just have the 9 sets of it, 9 groups of it. Well, what's that? Well, 4 groups of 29 is 1,000. Then 9 groups of 1,000 is, guess what? 9,000. See how easy? Remember I taught you guys when it gets tricky to circle the digits you're going to be multiplying and then underline the zeros. 9 groups of 1 is 9. And then I underline those zeros there. All right, so that's how that commutative property can help you solve that. So let's try some more problems with that. You ready to go? All right. Trying to see where I am. All right, don't worry about that because I gave you the answer. All right, so then there's a lot of different numbers that we're going to be talking about in the future, but we're not going to deal with that. We're going to just review today with you guys some strategies that we've learned. Multiplicative comparisons. write an equation. So try these out, stop the video, and I'm going to go over every one of them. So pause the video, give yourself literally 5 minutes at the most and work these out. Go. All right, let's see how you did. I put a multiplication chart there to help you. All right, so I kind of wrote these problems down for me, and then I'm going to show you some key things. So did you remember that when you're doing comparisons, what is equal to? Is equal to the equal sign. Times is equal to the multiplication sign, right? So I can already just kind of go through these problems, and everywhere I see a times, I put a times, right? That's pretty easy. All right, so I have to make an equation. 12 is 3 times more than a question mark. Well, what number is missing? What number times 3 is equal to 12? Hopefully you realized it was 4. 4 groups of 3 is 12, all right? So here we go again. Build it. 6 times more than 7 is, well, what's 6 groups of 7? 42. So we need to learn the language, and that's what makes 4th grade a little bit more trickier. It's not just calculating anymore. You could do some of this like backwards. It's actually understanding the words and how they're being used. So hang in there. Every day you're going to get better and better. All right, so Olivia has 5 Pokemon cards and Liam has 8 times more. How many does Liam have? See, I find these really tricky, so I'm going to build a model. So Olivia has 5. Do you remember that? And Liam has how many times more? 8 times more. So this is that model. 1, 2, 3, 4, 5, 6, 7, 8. So here's Olivia and here's Liam. Liam has how many times more? 8 times more. So Liam has 8 groups of 5. 8 groups of 5 is 40. So Liam has 40. But then it asked me how much they had all together. So here's where I would do them all together. Well, it's not just Liam's 8 groups of 5, but it's also adding Olivia's 1 group of 5, which is equal to 5. So all together they have how many? 45. All right? All right, so let's go on to our next review. All right, then we were multiplying tens, hundreds, and thousands. So you had to figure out how to use a number line to help you and just what was the pattern of using zeros. So pause the video and give this a go. And you notice there's a multiplication square if you need it. All right, I'll bet you some of you found this tricky because I went back and I realized I'm not sure if we anchored this well. So let's take a look. How can a number line help me solve 5 groups of 6? Well, some of you are already doing that in your head. So here you have a number line. It starts with 0. Okay, I have 5 groups of 6. So here's my first group of 6. Here's my second group of 6. Next group of 6. Next group of 6. And next group of 6. 1, 2, 3, 4, 5 groups of 6. Okay, so if I had a number line, what would that be? Well, that would be 6, 12, 18, 24, and what would be the next one? 30. So when you're using repeated addition, you are actually making those jumps on a number line, and you are counting by 6s. So this is how a number line can help you. Now, how does that then help you with 5 groups of 60? Well, guess what? It's literally just adding that 1 0, right? This was what your original factors that you sort of broke apart, and then the pattern is adding that 1 0. So look, I just added a 0 to the top, and I just add a 0 to the bottom. So instead of doing jumps of 6, I'm doing jumps of 60. Instead of going 6, 12, 18, 24, 30, I'm going 60, 120, 180, that one's not as clear, 240, 330. And can you show me what a number line might look like for this one? See if you can sort of race me to it. Okay, 1, 2, 3, 4, 5 groups, right? And then each one now, instead of just 6, here I'll make my 6s go upwards so they're neater, because they're kind of hard. I put 1,000, and you see how I make the zeros little? I do that for a reason, to tell my brain it's a pattern. All right, so I know that normally this would be 6, 12, 18, 24, 30, but what's my pattern? Adding how many zeros? 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. So anytime you see zeros in a multiplication problem, on the end, by the way, that would be very different if it was like 606, right? Because that strategy doesn't really work the same way. But when you see them at the end, you know that you are just worrying about the first digits and then adding the zeros at the end. And that's how a number line might help you see it a little bit clearly. All right, so the next problem was, what do you notice about zeros when you multiply 8 groups of 90 and 8 groups of 9,000? Well, it is the same thing, okay? Oh, I lost it. So, problem number 3, 8 groups of 90, 8 groups of 9,000. One digit in every box. I circle the key facts I'm going to do, and I underline those zeros I'm going to add. So what is 8 groups of 9? 8 groups of 9 is 72. How many zeros do I add? 1. 8 groups of 9, 72. How many zeros do I add? 3. And you notice I don't add my commas until the very end. Makes it a little bit easier. So what do you notice? Well, my key factors were the same, and they both multiplied into being 72. But however many zeros were at the end of either factor got added to the end. Now, what would that look like if it was 80 times 900? Believe it or not, it would be the same answer. 8 groups of 9, which would be what? 72. And I'd have 1 0 on this side and 2 zeros on this side. And look, isn't that interesting? So 8 groups of 9,000 is equivalent to 80 groups of 900. So that is why I circle those digits to make them really clear so you can pull them out to multiply them. And then I just have those zeros left, which I underline and I add them. All right, so we're going to keep that problem up here because then it's actually to really think about what is the difference in numbers and zeros between 8 times 50 and 8 times 5,000. All right, well, I noticed we're doing 1 0 here and 3 zeros there. So I'm thinking the numbers should be the same, right? So let's see. I'm going to do it in a different color. And I'm actually going to do it right at the top. So it wanted me to compare 8 groups of 50 and 8 groups of 5,000. Well, if I'm not really just thinking about it, I'm thinking about patterns. I'm thinking, well, the answer here, whatever I have, should have how many zeros? 1. And the answer down here, the product or the multiple, should have how many zeros? 3, right? Well, let's see. First thing I do, remember, is I circle those factors I'm going to multiply. Well, 8 groups of 5 is 40. That has its own 0. And that's why I taught you, remember, to circle this at the beginning, because that 0 in that product belongs to this 8 groups of 5. So now I have to add a whole new 0. Okay, this 8 groups of 5 is also going to have 40, but I have to add to them 1, 2, 3 zeros from the 5,000. So there was a difference. This product only had 1 0 because 8 times 9 came up with 72, which had no 0 of its own. This one, 8 groups of 5, had a 40, which had its own 0. So then when I added the 0, it had 2. Again, 8 groups of 9 came out to be 72. This product had no zero of its own, but 8 times 5 had a 40, which had a zero of its own. This one I added the 3 zeros from the 9,000, and this one I had to add the 3 zeros from the 5,000 to the 40. So this one will always have one more zero because the multiple of 8 and 5 has its own zero. Hopefully that makes sense. You guys are doing fabulous. Hang in there. Okay, then it wanted you to estimate the product. And I think this is where you guys were getting kind of confusing because we didn't do it with addition, but I thought it would be easier here. And even though it might seem complicated, it's going back to those properties of 10 and 100 and thousands. And what it's asking you to do is this idea of reasonableness. And do you know if your answer is reasonable? So the first thing I want you to do is estimate the product of 5 groups of 2,213. Just estimate it. And then we're going to estimate the product by finding 2 numbers. The answer is in between. And I'll show you how to do that. All right, and then we're going to find the real answer. And I'm going to show you how to do that easily. So 5 groups of 2,213. Just estimate. Pause the video, give it a go, and then when you see me moving the mouse again, start it. All right, hopefully you did it. Let's give it a go. 5 groups of 2,213. So 5 groups of 2,213. All right, so I have a lot of choices. I could round to the tens, right? Which would mean I would round to 2,210 because this 3 is 4 or less. So this one would stay rest. That doesn't seem much easier for me to solve. I don't know if 5 groups of 2,210. I could round to the hundreds, which would be 5 groups of, well, let's see, the 10 is a 1, so that's still letting this 2 rest. So that would be 2,200. So some of you might be able to do that one pretty well. Good for you, but some of you might find this tricky. So when you get to choose your estimation, you can go all the way to the highest place value. So this is the thousands, this is the hundred, this 2 is letting the 2 rest, so I can multiply 5 groups of 2,000. And all my numbers, all my things are going. Well, you guys can do this, right? 5 groups of 2,000. That's easy because you circle the first 2 digits. 5 groups of 2 is what? 10. How many zeros do I add? 1, 2, 3. So 5 groups of 2,000 is 10,000, right? That's pretty easy. So my answer here should be pretty close to 10,000. If it was 20,000 or 30,000, or let's say it was 30,000 for some reason I did it wrong, or maybe it was 300, I need to know that these answers aren't right because my answer, when I round it and I estimate, needs to be close to 10,000. So then the next problem said, well, give me some numbers in between that your number will be in between. Well, this is where I need to round high and round low. So I know that my answer should be between 10,000, which would be, but look, this 2,000 is a little bit less than 2,200, right? I still have 5 groups of 215. So my answer is going to be actually a little bit higher than 10,000. If I round to the next, let's say if I round up here a little bit, I estimate I could do 5 groups of 2,500. Do you see that? Remember I did that? And I know that 5 groups of my 25s, I can count by 25s. 25, 50, 75, 100, 125. So 5 groups of 25 would be 125. And how many zeros? 2. So my answer is going to be somewhere between 10,000 and 12,500. That's what it means to estimate. Now, can you find the actual answer? Pause the video and break this number apart to see if you can. While you're working on it, for some of you that aren't sure, I'm going to show you how to get started. I'm going to use partial product Remember that term? And I'm going to expand this number by its place value. Expanded form. So I'm going to have 5 groups of 2,000. Okay, I'm going to put a box around this one. I'm going to have 5 groups of 200 because there was a 2,000, 200, 10, and 13. So what's my next one? 5 groups of 10 and 5 groups of 3. And do you see how I kept my place value lined up on my paper? That's going to be really important. 5 groups of 2,000, 5 groups of 2 is 10. How many zeros do I add? 1, 2, 3. 5 groups of 2 again is 10, but 2 zeros. So I'm going to have to build this one backwards. 2 zeros for here and a 10. Ooh, that was tricky. 5 groups of 10. 5 times 1 is 5 and 1 0, so I'm going to build it backwards. And then 5 groups of 3 is 15. So I have to make sure I line up my place value of these partial products. 0 add 0 add 5. 0 add 0 add 5 add 1 is 6. 0 add 0 is 0. 0 add 1 is 1 and 1. So is my answer 11,065 between 10,000 and 12,500? It is. So when I rounded down to 2,000, I got the 10,000. And then when I rounded a little bit up from 2,200 to 2,500, because I kind of knew that my 25s, I got 12,500. My answer was right between there. Good job, you guys. All right, last but not least, hang in there. You're almost done for the day. All right, so try these out. Stop the video and then start when you are done. Remember, you can break up these numbers to make it easier. So you have to think about it. You can't just take them at face value. You are literally thinking about the facts that you know and what you can do to solve these questions faster. To find 7 times 23, is it easier to break it apart, the 23 into 20 plus 3, or 15 plus 8? You think about that, but you're going to solve for that problem. Then you're going to solve 7 groups of 12, 5 groups of 16, and 9 groups of 13. If you're not sure, we're going to work through every one, but I want you to try at least to write down on your whiteboard. I'd like you to break these numbers up to be able to multiply them the way you think would be easiest. And I'll show you this first one, 7 groups of 23. All right, so I have 7 groups of 23. If that's too hard, I'm going to break it up. I can break it up by place value, 7 groups of 20. All right, so I'm going to put a box around this one, and I'm going to add it to 7 groups of 3. And I can do that a lot easier, right? What's 7 times 2? 14. How many zeros do I add? 1. What's 7 groups of 3? 21. All right, can you add those together? 0 plus 1 is 1. 4 plus 2 is 2. Add the 1. So do you see I took the 23 and I broke it up into place value? So I want you to try that for the other ones. All right, so pause the video and give those a go. All right, I know you guys are probably tired, but you're hanging in there and we're almost done. This is a good review. And I'm going to keep this video, I'm going to attach it to our homework page so if you need it. And in the future we'll have smaller videos, okay? But this is just a big review. All right, so I had to make a decision here. So again, I can do it by expanded form and break it up by place value. I have 12 is 7 times 10 and 7 times 2. All right, and I'm going to move this problem down a little bit, but 7 times 1 is 7, add a 0, and 7 times 2 is 14. Lining up my place value, that gives me 84. All right, but what about 7 times 16, or 5 times 16? So I'm going to put 7 down here for me. 5 groups of 16. Again, I could have done it 5 groups of 10 plus 5 groups of 6. Is that easier? All right, or guess what I could have done? I could have known that 16 was 8 plus 8. So I could have done 5 groups of 8 plus 5 groups of 8, because what is 16? 8 plus 8. So remember, you can break up that 16 using the distributive property into whatever way you add that. But no matter what, this 5 groups doesn't change. So what's 5 groups of 8? 40. 5 groups of 8 is 40, so guess what the answer is? 160. I can check myself. 5 groups of 10 is 50. Whoops, sorry. 5 groups of 6 is 30. What did I go wrong? Did I do it wrong? That says 80. Oh, I'm crazy. You guys didn't catch that? I was still multiplying. 40 plus 40 is what? 80. So see how good that was? That was like a total perfect self-check. So if you ever just aren't sure and you have time, go back and check your work. All right, last but not least, how do you want to break up the 9 times 13? What is the easiest way for you? Well, a lot of you love your 10s again, so I love those properties of Euro. 9 times 10 is equal to what? And 9 times 3. So I add those add-ins that make 13 together. Well, what's 9 groups of 10? 90. And what's 9 groups of 3? 27. So do you have to know your multiplication facts? Oh, yeah. There's no way to get around this without it. All right? So that is what the lesson was about previously when you were using the distributive property. It was just trying to help you break up these tricky factors, because 16 is a factor, right? 5 times 16. These are the two factor pairs. Trying to break them up into parts that you know easier. So if I can break up 16 into 8 plus 8, and I know 5 times 8, that's easier. Or if I can even break up 19 into 9 plus 10, that's easier than multiplying any number times 19. All right. Expanded form, we've kind of been talking about this, and we're going to start to slow down. I think I even had one more video after this, but I think we're getting tired. So I'm going to bring it all together. The expanded form is the distributive property, and then the next one was partial product, which is all of it. All right, so I'm going to show you right here, 2.7. That brings us up to SPAR. All right, so let's pause the video. I want you to break these up by place value and just show your work. Don't worry about the way it's modeling it, and I'm going to show you. So just break up 53 into 4 groups of 50 and 4 groups of 3. 473. 9 groups of 400 times 9 groups of 70 times 9 groups of 3. Do you see this? 608, 6 groups of 600, 6 groups of nothing, 6 groups of 80, and then we're going to add them together. Now, the first thing it asked you to estimate, so I'll do that with you as well, just to check to see if our answer is about right, and don't be afraid to use your multiplication tables for the while. All right, so if I'm estimating this, all right, well, this 3 is pretty low, so I'm going to say 53 is very close to 50. Well, what is 4 groups of 50? 50, 100, 150, 200. So my answer needs to be really close to 200. This 473 is really close to 500. Would you agree? So I'm going to say 9 groups of 500. Well, what's 9 times 5? 45. How many zeros? 2. So my answer should be close to 4,500. This 608 is really close to 600, and I'm going to have 6 groups of that. So 6 groups of 6 is 36. How many zeros? 2. So my answer here should be really close to 3,600. Will any of these answers be the actual answer? No, because this isn't 4 groups of 50. It's 3 more groups. It's 53 groups of 4. It's not 9 groups of 500. It should be less because it's only 9 groups of 473. It won't be 3,600 because I don't have 6 groups of 600. I'll have a little bit more because this is 6 groups of 8 or of 608. So how do we do it? Again, whatever you want to call it, distributive thing, partial product, expanded form. I change it from this direction for right now, and I make it 4 groups of 53. And that's going to be really different, maybe for even your parents. That might be new to them. 9 groups of 473. 6 groups of 608. All right, I write it horizontally because I'm going to break it up by what? Place value. Do you see that? And I can't do these all in order because they're too crunched together. 4 groups of 5 is 20. Add a 0. 4 groups of 3 is 12. The answer here will be 212. Is that close to 200? Absolutely. Do you see that? So I'm going to erase this one so I can use it, the space over here. So I'm going to break this up into 9 groups of 400, 9 groups of 70, and 9 groups of 3. That's a bad example of keeping a digit into there, so I want to do that. Equal sign, okay? 9 groups of 4 is 36. I'm ignoring this problem right now. How many zeros? 2. Okay, I'm going to put a line there so I don't do it. 9 groups of 7, 63, but I have a 0, so I'm going to put that 0 there. 3 and 6, because I need to line up the place value. Where I sometimes go wrong is I'll do 9 groups of 7, I'll put the 27 here, but really that's 7 ones and 2 10s, so I need to keep them in order. Not counting for this problem, 0 at 0 is 7, plus 7, 0 plus 3 plus 2 is 5, 6 plus 6 is 12, carry the 1, it's 4. So 9 groups of 473 is 4,257, which is really close to 4,500. So I'm right. And was this estimate a little bit higher? Absolutely, because this was a little bit lower. All right, I'm going to erase this problem. And I'm going to actually write this problem a little bit neater over here. So this was problem number 7. 6 groups of 608. And don't be afraid to use paper. All right, so I'm going to put a little box around it so I don't mess it up. Break it up, expanded form, partial product, whatever you want to call it. 600. 6 groups of what? Nothing. No 10s. 6 groups of 8 ones. Equal, equal, equal. Is. 6 groups of 600 is. Okay, 6 times 6 is what? 36. How many zeros? 2. 6 groups of nothing, 0. 6 groups of 8, ooh, do you know that what it is? 48. 0 add 0 add 8, 0 add 0 add 4, 6, 3, and hopefully you're neater than me, I'm getting tired. So the answer for 6 groups of 608 is 3,648, which is really close to 3,600. And is this my answer a little bit higher? Yes, because I was 608. All right, so that's how you use expanded form, partial product, whatever you want to call it. Okay. Why do they put it vertically? I'll show you really quickly with this one. They put it vertically because you do your ones first. 6 group of 8 is 48. Then you do your 10s first. 6 groups of your 10s is nothing. But you can't, it isn't 6 times 6, it's 6 times 600. And that's why I like to do it this way, because it's really clear, where this way I make a mistake, because some people want to put 36. But remember, if this is 600, there's how many zeros? So I need to put those zeros here. And that's why I would rather work it this way to show partial product and expanded form than try to do it vertically. When we start doing standard algorithm, and I'll show you that, we will do it vertically and it'll be pretty easy, but this really will get you very far using single digit by any number. So this is just a really great strategy for single digit by any number. All right, and last but not least, that's what that was. And this is what 2.7 was. It was exactly the same thing, but look, now instead of hundreds, you're into thousands. So it's no different, just keeping it organized and breaking it up into those place values. And I'm going to do this last one because you've got to be tired. You've worked for over an hour. Let's just jump here. 8 groups of 8,145. I'll do it for you. How's that? 8 groups of 8,145. Okay, that probably looks impossible for some, but remember, breaking it up into place value. 8 groups of 8,000. 8 groups of 100. 8 groups of, and you notice your place value, right? Goes right here, 40. 8 groups of 1s, 5. And so do you see how I do that? I keep it all lined up. Equal, 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 because that's your is. 8 times 8. 64, how many zeros? 1, 2, 3. 8 times 1, 8, but now I don't write it. How many zeros? 2. I start here. 1, 2, 8. You got to work it backward. 8 times 4. You have to know your multiplication. That's 32. How many zeros? 1. So I took that 1 0. 32. 8 groups of 5. 40. Adding them all together. Zeros. 2 plus 4 is 6. 8, 9, 10, 11. 1 plus 4 is 5. And 6. So hopefully this idea of partial product, expanded form, whatever they want to call it, but partial product is using expanded form. It's using that distributive property because you are breaking up numbers into their addends. You are breaking this number into what you can add to make it up. And then you're multiplying it by your same groups of to get the answer. All right, so for some of you, you're going to have homework in 2.7. I have some extra problems here if you feel like keeping going. Give it a go if you're not too tired. This missing digit actually we'll do tomorrow, actually, so I'm going to pass that. Thanks for hanging in there with me, guys. I know it was hard. You do have homework tonight, and Miss Jennifer will give it to you. You have a great day.